We are going to pick up with the diagrams. I believe the diagrams are a better teaching tool, or reading your information and looking at the diagrams at the same time, because these are in your book. So if I start looking at, here's the superior vena cava. It drains blood, it brings back used blood from your head, from your arms, the upper part of your body. Your inferior vena cava is bringing blood back from the lower part of your cavity, and both of these empty into the right atrium. And like I said, diagrams, if you look at a real heart, this atrium, when it's not full of blood, it's not this large. It's a little bit deceptive. But blood comes into the right atrium, no oxygen. It's going to simply drain down into the right ventricle. Here's that coronary sinus. So here's where the blood from the heart muscle drains in. Everything comes into the right atrium. Drops down into your right ventricle, goes through tricuspid valve. 3 cusps. Here's those chordae tendineae. They are very, very strong little stringy-like structures. And then here's those papillary muscles that they attach to. So right atrium, through the tricuspid valve, into your right ventricle, squeeze up through. This valve leads to your lungs, so this is the pulmonary valve. And this is going to be the pulmonary trunk, and it's going to go to your lungs. So then blood goes to your lungs, it picks up oxygen, gets rid of waste, gets rid of carbon dioxide, and then it comes back through pulmonary veins that lead to the heart. Notice they are red because they have oxygen. They are the only veins that will ever be colored red on a heart diagram. And this is your only artery that will be colored blue, because this is leaving the heart, but it's going to the lungs. These arteries are coming, or these veins are coming from your lungs, so they have oxygen. So, oxygenated blood comes in on the left side of your heart, enters the atrium, drops through the mitral valve, or bicuspid, it only has 2 cusps, into the left ventricle, which has a thicker lining because that big squeeze is going to send blood up through the back through an aortic valve that goes into the aorta. From the aorta, blood is sent upward, blood is sent downward, blood is sent to the entire body, carrying the oxygen that it needs. So as far as diagrams go, this diagram you should know. This is, I completely expect you to know all of those parts. This table just shows the blood, or the valves and their function. Tricuspid and bicuspid are AV. They separate the atrium and ventricle. Pulmonary is going to go to the lungs. Pulmonary means lungs. Aortic is going to go to the aorta. So those are fairly easy to remember. How these valves actually look, you can see a real diagram of a heart that's been cut open. They are very thin. It's amazing that those thin valves can work for 80, 90 years and not deteriorate more often than they do. There are valve replacements. A former student of Artesian Letcher has a titanium valve that is put in her heart, and you can actually kind of hear it click when it closes. Pig valves, they used to use pig valves to replace human valves. So if you have a problem where there's too much backflow, you'll have to have your valve replaced. It is very common to have a little bit of backflow, and that creates a heart murmur, which is just a little, it's a small amount of backflow, and that's usually not a big thing. The skeleton of the heart, basically dense connective tissue, surrounded the pulmonary trunk and aorta. are going to be attachments for the heart valves and fibers. The tough rings do prevent dilation of the tissue. You do not want it to dilate too much. Blood flow deals specifically with the diagram. So if you can memorize or you know that diagram that I said you needed to know, this completely goes with it. Blood comes to the heart without oxygen. It's used up. It's going to come to the right side of your heart, empty into the right atrium. From the right atrium, it drops to the right ventricle. Then it's squeezed up into your lungs to pick up oxygen. And then once it has the oxygen, it's going to come back on the left side of your heart into the left atrium, drop down into the left ventricle, and then come up through the aortic valve and sent to the rest of your body. So this slide completely goes with the diagram of the heart. If you know the structure, you should know the blood flow. And like I said, I expect you to know both of those. I do want you to know your heart beats top, bottom. So your atrium contracts, squeezes blood to the bottom of your heart. Your ventricles contract and squeeze blood out of the heart. So when your heart is beating, it's a top-bottom squeeze is basically how it works. And you can read, I pretty much gave the spiel on this slide when I was describing what happens. So here we're talking about the oxygenated blood. That's going to be on the left side of the heart. So pictures again, here we go. I have used my brain. My brain has used oxygen. I have carbon dioxide as a waste. So my deoxygenated blood, superior vena cava into the atrium. Inferior vena cava, used blood, deoxygenated blood into the right ventricle, drops down, comes up, goes out to your lungs, and that's where your oxygen is exchanged for carbon dioxide. You breathe out to get rid of carbon dioxide gas. Your lungs use the oxygen. Comes back, all comes back into the left side of the heart, left atrium, drops through the mitral valve, left ventricle, out the aortic valve, into your aorta, and then this will become the descending aorta that drops and branches off for blood to go all over different parts of your body. Actual blood supply to the heart, again, coronary, whenever you see that word, deals with heart. The first branches off the aorta are the right and left coronary arteries. So the very first branches on the aorta go directly to the heart muscle itself. Excuse me. And then branches of these coronary arteries are going to feed tons of small capillaries that are inside of your heart. Your heart works constantly. It's the strongest muscle in your body. It needs a large supply of oxygen. Blood flows the best when the heart is actually relaxing or in between beats or in between squeezes, because the contraction squeezes the blood vessels, and when it squeezes, those blood vessels can kind of close. Picture, this just shows your aorta leading into the coronary arteries, which, when you dissect a heart, those coronary arteries are kind of hard to find because your fat, you will have deposits of fat on the heart. So even if you dissect a pig heart, a sheep heart, there's going to be fat areas around those coronary arteries. So if you know someone who's had stents put in to their coronary arteries, one of the reasons that's very common is fat tends to accumulate on the heart. Let's see. So heart muscle requires a continuous supply of oxygenated blood. Smaller branches often have anastomosis as alternate pathways for blood if one becomes blocked. So your heart itself if it has some blockage, will kind of form different vessels. And the same thing happens if, you know, sometimes they will actually remove an artery or a vein, and then a new one will kind of take over for that blood flow. Cardiac veins then are going to drain blood, used blood from the heart. It's going to go to the coronary sinus, and that, like we already said, empties into the right atrium. So picture this shows some of the arteries and veins on the outside of the heart. So these are the ones that feed the heart. So here is the right coronary artery, the main branch. Here's the left coronary artery, the main branch, and then notice that it branches into smaller on both sides. A great cardiac vein is the largest vein that drains or empties the heart. And these smaller ones, anterior side, it's the front. Apex, I don't remember if that was labeled before. Apex is the bottom cone part. The apex is this cone part at the bottom of your heart. I don't remember if I pointed that out before. So then here's just the back side. So now we're going to have posterior. These little branches are going to be posterior arteries instead of anterior arteries. But here again, so here's the coronary sinus that's on the back side of the heart that drains the heart. And that extends into the great cardiac vein that wrapped around to the other side of the heart. And we will stop there, and we'll talk about actual actions of the heart next time.